Hi everyone and welcome to Miss B Maths Teacher channel. Today I'm going to talk about finding the equation of the tangent to y equal to 1 over sin to x at the point where x is equal to pi over 4. The first thing that I'm going to do, the first step is to find the point of contact. So the first thing, I'm going to put number 1, finding the point of contact. Point of contact, just get it, yep, point of contact when x is equal to pi over 4. So we're going to substitute the value of x equal pi over 4 into our equation y equal 1 over sin to x. So instead of x, we're going to replace x with pi over 4. Okay, let's do it. So for y is equal to 1 over sin times 2 times pi over 4. We can cancel out 2 and 4, which is going to give us 2. And 1 over sin of pi over 2 is equal to 1. So you can use unit circle or calculator to calculate it. But sin of pi over 2 is equal to 1. So therefore, the point of contact is, I'm going to use different color, point of contact is pi over 4 and 1. So let's go with that one again. Okay, so it's, yep, pi over 4 and 1. That's the point of contact. The next thing that we're gonna do is actually to find the derivative of the function. So find the first derivative. It's gonna be number 2. So and before I do that, I'm just gonna rewrite this equation, 1 over sin 2x, and I will rewrite this in the form where I'm gonna move sin 2x in numerator, and that's gonna become negative 1. Please note that this negative 1 here, this negative 1 doesn't have to do anything with this one that's in numerator. So this one in numerator pretty much is the number here, 1. We just don't write 1. So now let's find derivative, and y dash, I'm going to change the color, I want to be blue. So y dash is equal to, we're going to use chain rule. By using chain rule, we're going to take this power in front of the brackets. So it's going to be negative 1. Copy everything that we have inside the brackets, which is in this case sin of 2x, and the power negative 1 is going to decrease by 1, and it will become negative 2. So it's negative 2. Now we have to find the derivative of whatever is inside. So that's the chain rule. So power in front, so it's negative 1. Copy everything that you have inside, decrease the power by 1, and now we have to find the derivative of sin 2x. So derivative of sin 2x is, so I'm just going to write here on the side, if function is given by sin of f, okay, let's have it a little bit bigger. So if function is given by sin of f of x, like that, derivative is gonna be cos of f of x, and then derivative of f of x. So we're gonna apply the same rule here. So this is y dash. Same rule applying here. So derivative of sin of 2x, it is equal to cos of f of x, in our case is 2x's, and then finding derivative of 2 of x, which is derivative of 2x is times 2. So times 2. let's tidy up this a little bit. So y dash is equal to, I'm gonna keep this part in numerator, so it's gonna be negative and negative 1 here, negative cos of 2x, and I'll take this number 2 here in front of the bracket, in front of cos, so it doesn't make any difference. So it's gonna be here, I'm gonna just put here negative 2 over, and this part here, sin 2x everything to the power of negative 2, I'm going to put in denominator, and it's going to change the negative index into positive. So that will give us sin of 2x and everything to the power of 2. So now we do have the first derivative. So first derivative, please note that this can be written as negative 2 cos of 2x over sin 2x to the power of 2 is the same as sin to the power of 2x. So it's the same thing. So now we do have derivative. So the next thing, that would be my step 3, isn't it? So that's 2. And let's do step 3 on next page. So, other page, f of a is equal to 1. Step 3 would be, just change blue, it would be to find the tangent, the tangent at whatever value at pi over 4. That was our number, at pi over 4. And let's see what's going to be equal to. So let's just try this. Y dash is equal to, I think it was negative 2 cos of 2x over sin to the power of 2 and 2x. Let me just check that on previous page. Yep, that's correct one. So when x is equal pi over 4, y dash is equal to. Now, all we're going to do is every time we see x, it will be replaced by pi over 4. So let's go, yeah, pi over 4 replaced. So over sin to the power of 2 times, and again x will be replaced by pi over 4. And if we do calculate this, so y dash is equal to, it should give us 0, because this 2 and this 4 is going to cancel out. It's going to be cos of pi over 2, and cos of pi over 2 is equal to 0. So all these in numerator will be equal to 0. So all these will be equal to 0. So therefore, y dash is equal to 0. So the tangent at pi over 4 is equal to 0. Now the last step, the fourth one, is to find the equation of tangent. So equation of the tangent at x is equal to pi over 4. Different ways of finding it. So and I'm going to use this form today, y equal to f dash of a times x take away a and plus f of a. Now I'm going to replace those values, and it's going to give me this. So let's choose yellow. So it's going to be y equal to f dash at a, so which is pretty much this part here. When x is equal pi over 4, y dash is equal to 0. So it's going to be 0, and it's going to simplify it nicely. And x take away pi over 4 and plus f of a. F of a, it's on, so, and plus 1. All this is going to be equal to 0. So from here, Therefore, the equation of the tangent and x equal pi over 4 is equal y equal to 1. So this is our equation of the tangent. Tangent at x equal to pi over 4. So I hope this helped, and thank you for watching.